Dalton's law. So Dalton's law can be looked at in two different ways. The sum of Dalton's law basically says that the total pressure of gases in a container is equal to the sum of the individual pressures, and that all gases behave the same. So if I have a gas and I add another amount of gas, a different gas, then the pressure is going to increase, and that makes sense. This is assuming that the volume remains the same, because the number of particles that I add in are going to increase. And if I have a container in which 2/3 of the molecules are of one type of gas, that one type of gas is going to exert 2/3 of the pressure. So it should make sense. So I can say my mole fraction, which I can either say N1 or this chi. So the individual mole fraction, the amount of moles that I have of an individual gas over the total number of moles, is equal to the partial pressure of that one gas over the total pressure. So an example, if I have 5 moles of a gas and it exerts a pressure of 2 atmospheres, if 3 of those moles are of another gas were added, what would the new pressure be? Right, so 5 moles equals 2 atmospheres. One way I can think of it is if 5 moles equal 2 atmospheres, 1 mole is going to be equal to 0.4 atmospheres. Adding 3 moles would be equal to adding 1.2 atmospheres. So to the original 2 atmospheres, I add 1.2 atmospheres, I'm going to end up with 3.2 atmospheres as my total pressure, right? Because it doesn't matter. I now have 8 moles of gas. Each mole exerts a pressure of 0.4 atmospheres, so I have a total of 3.2 atmospheres. Notice I haven't even told you what the gases are because it doesn't matter. Here's another example. A container contains 6 moles of nitrogen and oxygen gas. The total pressure is 4.8 atmospheres. If oxygen gas exerts a pressure of 1.4 atmospheres, how many moles of gas are there? Well, I know that their total is 6 moles, so the proportion is going to be the same. The amount of pressure that the oxygen gas exerts over the total will be equal to the number of moles of gas over the total. So I isolate for the moles of oxygen gas and I get 1.75, and it should be less than 6 moles. And it should be about 1/4, right? Because 1.4 is about 1/4 of 4.8, and 1.75 is about 1/4 of 6 moles.